So I'd like to welcome everybody. I hope you're having a good day. Thank you for joining me today. The focus of this presentation is on using GEOB 3D confinement for the oil and gas industry to construct access roads and paths. Once again, thanks for attending, taking time out of your busy schedules. A little about myself. I've been the Chief Design Engineer with Presto for the last 14 years. Prior to joining Presto, I was an engineering consultant for 20 years, focusing on all different types of civil and geotechnical projects. I'm an active member on AREMA Rail Committees 1, which is roadway and ballast, and Committee 5, which is track. I'm also a member of ASTM D18, soil and rock, and ASTM D35, geosynthetics. So here are the things I hope you get out of today's presentation. Understand the benefits of using GEOB soil stabilization system for unpaved roads, drill pads, and working platforms, including the ability to use local, low-quality fill, recycle materials, and even sand. How the GEOB system can reduce cross-section depth and provide a more stable surface over soft subgrades. How the system reduces vertical pressures and sub-base movement. And finally, how 3D confinement can perform effectively when subjected to heavy loadings while extending the wear surface life along with reducing maintenance. During the presentation, if you have any questions, just type them in the chat window and we can address them at the end of the presentation. So Presto worked with the Army Corps of Engineers to develop geophilic technology in the late 1970s and held a dual patent with the Army Corps. We continue to be the leader in innovation of the geocell technology. We offer more than just a product. We work all of our customers from the initial concept phase through design and into construction to support a successful project. Our experienced engineers have the most knowledge of geocell technology in the marketplace. We provide full design support evaluations, no matter size of the project, and our assistance does not stop when the product leaves our door. We view every project as a team effort. We all need to work together to ensure a successful project. We do not recommend using standard tables or charts, since no two projects are alike, and should be analyzed based on the site-specific conditions. We have a worldwide distribution network, experienced not only in geotechnology, but other geosynthetics as well. We operate in 4 product areas using GEOB geocells, which can be used for load support, slope and shadow protection, and constructing green retaining walls. Porous pavements, of which we have both vegetated and aggregate solutions, and lightweight construction mats. Today we will focus on GEOB geocells, and in particular, how they are applied to construct oil and gas paths and roads. So let's begin with discussing how GEOB 3D confinement can provide benefits for unpaved surfaces. So the GEOB system consists of 2 main attributes. The first is the cell size. The cells come in 3 different diameters, including 20V, which is 8.5 inches in diameter, 30V, which is 10.5 inches diameter, and 40V, which is 18 inches diameter. We have 5 different section depths, 3 inches, 4, 6, 8, and 12 inches. We have different cell lengths consisting of 18, 21, 25, 29, and 34 cells in length. The actual cell size and height depend on site-specific project details and site conditions. So as I mentioned, Presto will provide that free evaluation, including a written summary, calculations, cross-sections, and specifications, once again, no matter the size of the project. And like I said, we do not recommend the standard charts and tables. The ultrasonically welded seam, where all of the connecting points are located, is very important to the function of a geocell. The stronger the seam strength, the better performance of the geocell, period. A strong seam allows for better lifetime performance. GEOB is produced using high quality, virgin high density polyethylene resin for consistent, strong welds at the seams, while also maintaining semi-rigid ductile properties. High stress crack resistance, overall toughness, and long-term durability. GEOB geocells do not use any fillers, exotic polymer alloys blends, which can ultimately reduce weld strength, that are offered in some competing products in the name of increasing cell wall stiffness and lowering cost. To avoid weld failures, the damaging effects of differential settlement, uniformity and performance of a geocell system is much more important than stiffness alone. Here you can see a typical GEOB panel. It comes tri-folded on a pallet. Each section, here you can see the tri-folded. It comes with a nominal width. Each panel has a nominal width. It expands like an accordion. Different section lengths, anywhere from 18 feet up to about 52 feet. And if you have a large type project, we can actually custom make the length to meet your project conditions. A typical pallet, they ship very economically to the job site. A typical pallet has approximately 3,500 square feet of material. So in order for a geocell system to perform uniformly, it is critical that both the factory welded junctions, which are the internal junctions, and the field joint junctions that connect into individual panels, as well as the mechanical junctions, perform at a level that is commensurate with that of the cell walls. Therefore, any incremental improvement in one characteristic, for example, the cell wall stiffness or RIA-CR, is only valuable if a complementary improvement has been made in the other components of the system, including the seam. GEOB is manufactured using a proprietary blend of high-quality virgin HDP resin. Our proprietary formulation has stood the test of the time for more than 40 years and contains no fillers, unstable polymer combinations, or exotic polymer alloys. For most typical sites, GEOB retain its durability for greater than 100 years, with lab testing indicating 149 years without degradation, even at full exposure to the elements. We stand behind our numbers so you can deliver certainty in the solution as you build with the materials that you trust. GEOB and all of our accessories are 100% made in the USA. Do not have any products that come from outside the United States. The system components are all of the supporting pieces that help the GEOB system protect the surface and sub-base layers, and also ensure relatively uniform performance of their interconnected system, thereby protecting against the damaging effects of deformation and differential settlement in response to applied vertical loads. Presto GEOB is equipped with numerous design and construction components that increase strength and speed installation for all of our different projects, whether that's load support, slope and channel protection, or earth retaining walls. For load support applications, which we're focusing on today, the AtriKey is the major component for a completely integrated system. AtriKeys connect the GEOB panels into a single system. The AtriKey speed installation are made out of 100% plastic and will last the lifetime of the project. AtriKeys ensure that the panels will not separate and that the GEOB system will not fail under anticipated loads. The specific engineering values of the AtriKey will ensure the system holds up to loading over time without the corrosion seen in staples or the failure of underperforming. The purpose of geocell confinement is very simple, and that is to stabilize the movement of unstable soils, whether that is both horizontally and vertically. It is an engineered system integrating multiple geosynthetics with the best method of confinement and subgrade stress reduction. Although today's discussion will focus on our unpaved access roads and pads, we do have the other applications which I mentioned. We have slope protection, channel protection, and GEOB walls. If you have any interest in any of the other applications, please reach out to us and we can discuss. We also have a great website with a ton of information. I'll touch on the website at the end of our presentation. Here's a typical cross-section for load support application. We start with a subbase of varying strength, typically expressed as the California bearing ratio, or CBR. We can also use blow counts. Then we decide if we need a geotextile separation layer, whether that's a woven or a non-woven geotextile. That's based on the application and the subgrade type. When we speak about woven geotextiles, we are referring to enhanced woven geotextiles and not slip tape wovens. As most of us know, split tape wovens do not allow drainage, which can lead to pore pressure buildup, potentially global failure of the road. So we want to make sure that we're using the enhanced type woven geotextiles, which allow the flow of water to flow freely up and down through the cross section. When using non-woven geotextiles in low subgrade CBR areas, it is important to be aware of the fines content. Non-woven geotextiles are 3D in nature, so the fines can actually migrate up into the non-woven geotextile and clog the openings, which can also lead to pore pressure buildup. So non-woven geotextiles are typically considered clogged before installation with fine contents higher than 15 to 20%. So just make sure that when you're doing your project, and we'll work with you too on the subgrade and the soils report if you have the information, what type of geotextile is required for your project. Depending on the type of load and the subgrade strength, we may need a subbase layer on top of the geotextile. Whenever we have a subbase layer on the or above the geotextile and below the geoweb, we typically burrito wrap the sides. So we bring the geotextile up and we wrap it around the sides so we don't lose any of that subbase into the poor soil next to it. Then we'll fill the geoweb. Materials laid down. Once again, you can be filled with any low quality aggregate. We can use, we'll talk about today, we can use pit run, crusher screening rejects, we can use sand, low quality aggregates, recycled materials. And we'll have typically a surface course. We'll have a wear surface on top of the geob to prevent the top of the panels. Typically, it's about a minimum of a 2-inch wear surface. And depending on the amount of the load and the subgrade strength, that could range anywhere from 2 to 6 inches. But we don't want to get too much on top of the geob because then you're just going to have more running of that surface course and then supporting the given load. So geob 3 confinement works this way. When a vertical load is applied, the active earth pressure in the loaded cell pushes back against the passive earth pressure in the adjacent cell to form a stable system. So each cell helps support the ones around it. The geob cell walls also transfer hoop stress, which is important in keeping the system intact and creates what is known as the mattress effect. So the strength of the seams around each cell, the material stiffness of the individual strips, and the connection method between the panels are all important factors in determining how the geocell system can improve site condition. So strong seams, semi-ductile resin properties, and integrated connections are critical to uniform performance of the installed system over the life of the project. In a load support scenario, vertical deformation can only occur with compaction or through lateral movement of the soil. So by spreading out the load in the classic approach, one can reduce compaction of linear cells, but only with cellular confinement can you assure no lateral shifting or running. So here you can see the stresses on the subgrade with the unsupported subgrade on the left and the geob reinforcement on the right. Please notice how there's a complete elimination of the highest stresses at the surface with the geob reinforcement. So the stresses are reduced and distributed over a wider area, which, as I mentioned, is called the mattress effect. The mattress effect reduces stress reaching the subgrade and leads to a significant decrease in deflection and running. The second main attribute of the geob system is the infill. I mentioned previously, the important benefit is that even a low quality aggregate, recycled materials such as crushed concrete, even sand can be used to fill the cells. Using recycled materials, low quality aggregates, pit run, crusher screening rejects, sand, save a significant amount of money on not only the material costs, but also the hauling cost. We can also, if interested, eliminate fines when desired, since the cells provide the confinement and aid compaction or cohesion with soils. So without fines, you can significantly improve drainage and let the water flow freely through the system, preventing pore pressure buildup and global failure. The ability to use sands, low-quality aggregate, really sets the geobe apart from other geosynthetics. Those products require high-quality crushed aggregates with high friction angles to achieve optimal performance. With the geobe system, low friction angle materials are just fine. The geobe panels achieve their full potential, even with these poor materials, which can be a huge cost savings. Here you can see the impressive load benefits of an 80,000 pound loaded dump truck, which is an Astro H20 loading and a partially filled geobe panel over a very soft subgrade. You can see how the cells push back against each other to support the load, and only the adjacent cells need to be filled for support. So you can see that with the active and passive earth pressure pushing back, only that adjacent cell needs to be filled to support the load. We'll now describe how geobe works at the surface to create a stabilized unpaved road or pad. So an aggregate surface has advantages in saving pavement costs. And with geobe filled with open graded base course, you can design a system that also allows for not only stormwater infiltration, but actually storage. Here's a typical type of subgrade that we are dealing with for the access road and pad projects. Very low CBRs, clay subgrades, high fine contents, very wet and saturated condition. This is a site in northern Canada where we've installed tens and tens of millions of square feet of geobe over the past 15 years for access roads and pads for the oil and gas industry. The subgrades are typically so bad and saturated that we need to install the material in the winter when the ground is frozen. I mean, here you can see a typical road over a CBR of 1 and less in certain areas. We grade the area, install a layer enhanced woven geotextile, typically with strengths ranging from 2,800 to 4,800 pounds per foot. And then we install the geobe layer. The depth of that layer typically is a minimum of 6 inches, but the actual size will be based on our evaluation. Same with the geotextile. The actual strength of the geotextile is, once again, is based on the subgrade strength and is determined when we prepare the calculation. Since it is an access road, a little bit of deflection is usually acceptable. We try to keep the deflection to around 2 inches. If less deflection is desired, by the owner, we can actually go ahead and prepare our calculations to limit that deflection. This is a remote access road to a drilling pad, as stated previously, so the subgrade strengths are so low, we need to construct it during the winter. Here you can see the installation of the enhanced woven geotextile with proper overlaps, based on that subgrade CBR. This installation had a very low CBR value, so we went with a minimum of 3 feet of overlap. We typically follow, Astro M288 and the geotextile manufacturer's recommendations for overlapping. So this contract has pre-assembled the geobe panels with the AtriKey connection device. This road was over 30 feet wide, so they pre-assembled 4 panels of geobe together. Remember that each one of these panels is about a nominal width of 8.5 feet. So once the 4 of these panels connected together, basically fills up that whole 30-foot wide road. The pre-assembling of the panels will significantly speed up installation. Once again, your aggregate is very expensive in these remote conditions, due to the cost of the aggregate itself, but also expensive to be hauled away or hauled in from very long distances away. So you can use those low quality recycled materials such as, of course, sand, pit run, screening rejects for infilling. Geobe is very easy to install in the field. You can see here that the contractor actually just cut some wood stakes to keep the geobe panels expanded, since someone forgot to put the rebar onto the truck. So the infill here, you see the truck just backs up and dumps the panels, or dumps the material onto the unexpanded panels. So there's no special installation techniques are ever really needed. You just dump and spread the material. Once the infill is dumped onto the edge of the panels, the material is just spread out, typically with a dozer or a grader, a lot of times with a GPS system. The access road project here used the local screening rejects for the infill. Since it was in such a remote section, it saved a lot of time material costs, but most significant savings in hauling costs. This is a project from a couple years ago. The customer contacted us and our distributor to discuss the options for rehabilitation of an existing access road that was failing. The rehabilitation was required to handle the rigors of a new plant expansion and commissioning. The existing access road originally served as a secondary access road into the facilities in the region. The access road had not been in use for several years and become almost impassable during spring and summer rain events due to neglect and lack of maintenance. So the customer asked for recommendations to provide load support options to drastically improve the performance of the road. So one of the main challenges was to keep the road operational during the initial subgrade prep and to stage reinforced material and gravel in advance of the road being closed for repairs. The execution plan for this road was only about 2 weeks. It's 7.5 miles long and 32 feet wide. So the project was successfully completely designed during a very wet construction season. Here you can see the roadway prior to starting installation. Subbase was pretty wet, subgrade strength, not that great, about 1.5% CBR. You can see the material has been staged on the side of the road. I can't mention enough that staging is very important. So you're not handling the material multiple times. It keeps the installation process moving at an efficient rate. We'll work with the contractors on material staging. So staging of the material and the geob infill is made more complicated on this sense. So there's a fiber optic line ran down this side of the road. So the contractor was not even allowed in that area. So we worked with our distributor owner to provide a recommendation that would provide a stable road service and the one that can be installed within the 2-week time frame. The initial deployment of the geopanels panels and enhanced woven geotextile, initially defined as very poor, were successful, so that a second layer was not required. And that's the second layer of geocells. A key to installation was the use of the AtriKey connection device. The AtriKeys, like I said, speed up that installation, and that's a side-to-side and end-to-end connections. AtriKeys are the strongest and safest connection method and allow for multiple panels to be connected and deployed at one time. The recommendation for this project was a 2,800 pounds per foot enhanced woven geotextile, our mid-size GeoWeb 30V, 6-inch deep panels, and a 3-inch wear surface. Since this road was 32 feet wide, the road will require at least 2 rows side by side of enhanced woven geotextiles with a 3-foot overlap. Based on this width and the subgrade to low subgrade CBR strength, it was determined during the evaluation phase to factory sew together 2 rolls of geotextiles to save on material used for the 3-foot overlap. We also use factory sewing of the geotextile to speed up installation to meet the 2-week construction window. When you need additional rolls of geotextile side by side, I would highly recommend reviewing the option of factory sewing the 2 panels together. Factory sewing eliminates the overlap, which on this project would basically save 3 feet. So you can imagine how much material was saved. Since the road was 7.5 miles long and the elimination of the 3-foot overlap, we saved over 20 rolls of enhanced woven geotextiles, resulted in material savings of over $40,000. That savings did not include the additional costs in reduced shipping and extra installation time. You can see in this photo the geotextiles factory sewn together and it is folded over before being placed on the roll. Then you just roll the geotextile out and unfold. Factory sewing also makes it very easy to pre-tension the fabric before placing the geob panels, since it is one large piece. So the cost of the factory sewing is very inexpensive. Sewing is usually less than the cost of material wasted by overlap, and sewing really speeds the installation rate. Other benefits in the field include no issues with trying to maintain proper overlap measurements and no issues with wind blowing open your overlap seam. If you've ever been on a job site during a very windy day, you can relate, because it is very hard to keep the overlap geotextiles in place. The contractor for this installation wanted the road width to be very precise. So once the woven geotextile was placed, the survey crew went and marked both sides of the road. You can see the stakes here and also the dashed line here where the panels went down. So the survey, the stakes on the side of the road, that was to keep the panels from moving when expanded. And you can see notice the minimum staking required. So prior to gravel install, the left edge is pulled and orientated to be right along the dashed spray painted line on the left side. Here you can see the geohub infill being stockpiled on the left side of the road. Then the excavator filled the 2 lanes down the roadway and transferred the remainder of the stockpile material to the geohub panels. As mentioned previously, that fiber optic line ran down the right side of that road. It was completely off limits. Here you can see an up-close view of the 2 tracks installed by the excavator. Once the excavator constructed the 2 lanes, smaller bobcats followed along and were used to fill in the remaining geohub, transfer the remaining stockpile material, and fill it in the geohub to get grade and crown. So once that was finished, a dozer was used to final grade the road. Typically, I mentioned before, dozers have a GPS unit for a consistent and final wear surface. For this project, we did recommend a 3-inch wear surface over the top of the geohub panels due to the number of passes. So the wear surface may be a little more when a roadway or pad is subjected to very heavy loadings. We have completed some projects using geohub for stabilization for walking drill rigs that have a very heavy loading and heavy footprints over a small area. And we use 6-inch wear surface for those applications. And here's the completed road finish in time with the wet weather. Remember that this project was 1.3 million square feet, 7.5 miles, 32 feet long. It was installed in 2 weeks with a little bit of downtime due to wet weather. Like I mentioned before, it's installed very quickly. And once the crews get going, a crew of 3 to 4 can easily install 3,000 to 4,000 square feet of geohub in an hour. This is an interesting project in South America. The access road was 6 miles into a production facility. You can see that during heavy rain season, the clay type soil got wet. Basically, there's no way to access the site. The subgrade was very soft, did not provide enough load support. So basically lots of strength, and you can see the severe rutting. The owner contacted our distributor, and we provided an evaluation to allow access to the site. The recommendation included a woven geotextile, our mid-size GW30V cell, 8-inch deep panels. So after the site dried out a little bit, the subgrade was prepared for installation of the woven geotextile. You can see here this geotextile is about 17 feet in width, and the road was a little bit less at 16 feet. So we have 2 geohub panels side by side connected with the entry keys. So each geohub panel has a nominal width, as I mentioned before, of 8.5 feet. So we just connected the panels together, just overstretched them a little bit. When the installation of a geohub, it's pretty flexible, so you can over or under stretch the panels to meet a certain width. You can see the owner wanted to have a very precise edge to the road, so they staked it almost every other cell on the side of the road. You can see it right here and on both sides. Interesting part of this project is rather than make the entire road wide enough to accommodate 2 vehicles to pass side by side, they added pull-offs to let vehicles pass every couple hundred feet. And you can see that right here. So about every couple hundred feet, they had this little pull-off area, so the vehicles just pull off and let another vehicle pass. You can imagine how much money that saved them versus constructing an entire 6-mile road, double that width. It's very easy to accommodate curves with the geohub panels since they're so flexible. You just over or under expand the panels depending on whether it's an inside or outside curve. Here you can see just them infilling with the locally sourced sandy aggregate mix. This area gets a lot of rain during rainy season. So the recommendation included the addition of channels adjacent to the roadway to divert the water away from the roadway. And here you can see those channels right here on the side. And also some pre-assembled geohub panels. So we went from this rutted, muddy, messy roadway that was basically completely unpassable to a finished roadway. So quite the improvement from the original that was severely rutted to this finished roadway. This is a really interesting project. This was an access road in a really swampy area south of Baton Rouge, Louisiana. The original design included a couple layers of geogrid. The contractor installed about 1,000 feet of that. During this time, that area got just pounded with rain, significant rainfalls, really low subgrade CBR, and due to the heavy loads, due to those low subgrade CBRs and the heavy rains, 1,000 feet of grid actually failed after a couple passes of the vehicles tried accessing the site for construction. So due to this, the engineer contacted us since we have worked on so many projects with them. We prepared a value engineered solution. So here we come up 1,000 feet was installed geode was removed, and replaced that with a layer of 4,800 pounds per foot enhanced woven geotextile. Our mid-size GW30V panels, 6 inches in depth. So the geodetic design, like I mentioned, had 2 layers of grid along with 16 inches of aggregate, high quality aggregate. So we accomplished a successful access road with a lesser quality and lower cost aggregate with a cross-section reduction of about 50%. Once again, you can just see the flexibility installed for the curves and roadway with really no issue. This roadway had a significant number of curves that we had to negotiate, so that panel flexibility is very important. Presto representative or one of our distributors will be on site to help the contractor negotiate curves, since it is very easy once you have done it, but it's very hard to explain in the installation manual. So once again, it's important to have on-site presence from the manufacturer to teach the contractor the tricks for a speedy and efficient installation. Once again, the infill is just dumped onto the unfilled panels and spread with a bulldozer. Typically you're outfitted with the GPS unit. The infill they went to here was a really low quality aggregate sand mix, which was pretty local to the site. So the owner saved, some money on the infill itself, but also saved money on some hauling costs. So it's a big advantage, especially now with aggregates. I don't know, a lot of you are seeing, but I'll tell you, it's really a shortage of aggregates in the U.S., certain parts of the U.S., Canada, and pretty much around the world trying to source a good high quality aggregate. Here you can see the final road, after construction. I'll talk about some drill pads. So for a typical pad, once clearing grubbing is completed and the drill locations are marked, a clay base is provided to control spills, leaks, drainage. You then bring in wooden swamp mats, to allow for construction equipment access. Then you bring in heavy steel mats are installed to allow the drill rig to operate on the pad. And when the drilling and completion works are finished, the mats are removed to allow for installation of the piles, piping, and electrical work. And since the clay cap doesn't drain well, once the mats and the wooden mats are removed, the clay subgrade needs to be reworked, reconditioned, and regraded. If the clay gets really wet, wooden mats typically can get pushed into the clay layer, and additional mats may be required. These wooden mats are heavy, typically about 15 by 20 feet in size. Therefore, you need a front end loader to move them around the site in order to replace them. The front end loader, as you can imagine, will further degrade the clay layer as it traffics across the site. We have been told by some owners that the rework costs can easily exceed $500,000 or more, depending on the size of their pads. Due to these rework costs and delays, several owners reached out to Presto and our distributor to evaluate the use of GEOB for the pads to replace the wooden mats based on success they had using GEOB on their roadways. So the advantage of using GEOB is you are building the pad up front and eliminating the need for the wooden swamp mats and any associated rework costs with the wooden mats. So when drilling and completion operations are finished for a typical conventional pad, they always place about an 8 to 10 inch gravel layer to support operations. By using GEOB versus the wooden mats, we reduce the requirement for reworking the clay, subgrade, and provide a clean, free draining platform to conduct operations, which actually reduces the life cycle cost. Often, construction of the pad, drilling, completion work, and then operations each have their own separate budgets related to a given site. By using GEOB, we reduce the overall construction cost by building a stronger and finished pad up front and eliminate all the rework costs. Some pads are now being constructed with liners, and we can still offer advantages in providing a more stable wearing surface and less maintenance. Since GEOB can provide a finished surface before any drilling work begins, you can imagine all the money saved. There's no wooden swamp mats are required. We will eliminate the rework costs associated with the mats. This is a very large drill pad. It had 24 horizontal wells. This is a pretty awesome overhead photo that shows the installation of the pad. You can see around the perimeter of the pad, they have installed a drainage ditch. The clay cap has been installed and compacted. For this pad, the evaluation showed we needed a 2,800 pound per foot enhanced woven geotextile in our mid-size GW30V 6-inch deep GEOB panels and a 3 to 4 inch wear surface. So once again, the GEOB panels are staged around the site to speed up installation. You can see the installation of geopanels and the enhanced woven geotextile are installed faster than the infill material. I can't emphasize this enough, but panels go down very fast with the AttraKey connection device. And to infill the geopanels, there are no special requirements for equipment or spreading out the infill. And like I said, we'll be on site for this. Our distributor was on site multiple times and multiple days for this site. You can see they have staged pallets of GeoWeb along the perimeter, pre-assembled sections of GeoWeb with the AttraKey connection device, and keeping up in front of the crew putting the infill in. Here you can see the plywood protecting the caps. Before GeoWeb is infilled, it's very easy to cut. Typically, you just use a razor knife. There's really not much strength to GeoWeb until it is backfilled and compacted. This pad used screening rejects for the infill, so it's a very economical infill. The workhorse over the top of the panels. Sometimes they'll bring in a crushed aggregate. There are significant benefits to using GeoWeb to complete the pad up front. Like I said, besides only the cost savings by limiting those mats, moving them all over the site, potential to add more mats to the clay layer, which, like I said, you eliminate all that rework of the clay. And GeoWeb also allows for improved site drainage as the water can flow freely laterally through the panels. This is the beginning of a typical pad that we've done multiple times for a major oil company. This is actually up in Canada. Each pad is about 325 feet by 400 feet, so a total of about 130,000 square feet. We worked with the owner and our distributor to come up with a pad design. This was a typical pad design when they had a CBR around 2%. You can see here the evaluation showed an installation of a 2,800 pounds per foot enhanced woven geotextile. As we discussed earlier, the seaming, the geotextiles in the factory, this project just overlapped separate rolls. It was a pretty decent CBR. So is it that way? Once again, this pad was approximately 130,000 square feet. You can just see the contractors pre-assembled a couple sections of GeoWeb together with the AttraKey. Each section here is about, we used our 34 cell, so it's about 230 square feet. They are pre-assembling 3 panels, so each section they put in is about 810 square feet. So the AttraKey really allows them to speed up the installation. Here you just see an up-close picture of the worker connecting the pre-assembled panels. I'm using the AttraKey. You can see an up-close photo. If you look down at the bottom or the side of the key on the right here, we've added frictional barbs to enhance frictional lockup with the textured GeoWeb cell walls. Together, these features provide added protection against the 3 primary modes of mechanical junction failure. Those include shearing, splitting, and peeling. So, like I said, it's a pretty typical pad, as I mentioned. The contractor in this pad used 2 crews of 3 workers, and they installed 130 square feet in 3 days. They were achieving installation rates well over 3,000 square feet per hour. So once again, like I said, the panels go down really fast. This same crew went to another site to install the exact same pad and layout. So the contractor tried to save a couple bucks and went with a competing GeoCell and their zip tie connection device. It took the same crew, the same 2 crews of 6 workers, 10 days to install the exact same pad, since they could not pre-assemble panels and had to install each panel separately. So it cost the contractor an additional 7 days of installation time and over $20,000 in extra labor costs to construct the same pad. As we all know, time is money, and project delays can be very costly. On these drill rig pads, for this project, if they would have showed up with the drill rig, as they did the last one, within 4 days after started construction, the pad would not have been ready. If that is the case, a lot of times they just typically take that drill rig and move it to a different project, which is ready. So we'll have to wait for another drill rig to get ready. So it can lead to a lot of time. So when evaluating products, it's really critical to look at the entire package versus just the material cost. Presto or our distributors, like I said, will be on site to help the contractor install the panels, including all the tricks, speed up that installation. We also have hundreds of installation videos we share during our pre-construction meetings with the contractors. Here is a finished picture of a completed drill pad. This is one that went with GeoWeb. This is what the pad looked like after 1 full season of drilling and completions work. So therefore, the pad went through 1 winter, spring, summer, and the following fall. The drilling operations used no wood matting through the entire process, and the surface of the pad did not need any rework prior to getting ready for infrastructure and tie-in work. The pad was constructed with geob up front. So this pad, you can see, is in tremendous condition, considering the abuse it had taken over 1 year of activities. As discussed, the advantage of geosystems do not need the wooden swamp mats. So that means two things. One, you don't have to pay to rent them. You don't have to move them around site with a front loader, or additional mats will not be required if the pad degrades. And two, you don't have to move them around the site, so you can access the ground-up place infrastructure like piles or electrical. So eliminating the wood mats leads to significant time and cost savings. So the right-hand photo shows the peripheral area of the pad. And it's in great shape after your drilling and completion operations. The left-hand side shows the piping and supports. And if you had wood mats, they'd have to all be removed before that installation took place. This is the same facility after 5 years of operation. After drilling and completions, the site was turned into a production pad. After 5 years, they have yet to rework the surface, even after all the vehicle traffic and maintenance equipment that have accessed production pad. So 5 years of operation without maintenance proves the impressive performance and cost savings due to using geob. So it's best to eliminate the wood mats by using geob up front and build the pads to save time, material, maintenance costs, and reworking of the pad. This project was a production pad that was not connected to a pipeline. Trucks were transporting condensate and oil out on a daily basis. So year-round access is required for equipment to service and maintain a conventional well site pad. Several new wells were also going to be drilled on the same pad, and since this location was not tied into a pipeline, you had continuous heavy tanker truck traffic that would need to access the site. So this picture shows a couple passes from a loaded tanker and how much damage and running occurs. This site needed almost continuous maintenance, so you can imagine why the maintenance costs were so high. The overall cross section here was about 8 to 10 inches of crushed aggregate, but as you can see, the fines have migrated from the subgrade below and have contaminated the layer, which is leading to the severe rutting. So due to the weak soil conditions, large ruts were being formed with the heavy vehicles. So the challenge was to provide a solution that was less expensive than matting, and that could be installed during the winter construction season and left in place for the life of the lease. The entire area that required stabilization was approximately 90,000 square feet. Pad was about 200 by 400 feet. So we worked closely with our distributor and the owner to come up with a recommendation based on actual site conditions, vehicle loading, and the number of passes. So once again, here we went with an enhanced woven geotextile. Once again, our mid-size GW30V cell, 6 inches in depth, with a 4-inch wear surface. Here you can see once again the workers connecting the panels together with the attic keys. Geob sections are very easy to deploy and install with local crews, even in remote or difficult access locations. The only training that is required is the tricks that I've discussed to speed up installation, which we will provide prior to startup. So once again, a representative from Presto or a distributor will be on site to assist with installation. To save further costs, the contractor used screening rejects, which work just fine, as mentioned, and fine inside the panels. I mentioned previously, you don't have to have a high quality aggregate to achieve stability with the geob. We can use those low quality aggregates. So when we developed the geocell technology back in the late 70s with the Army Corps of Engineers, geob was actually called SandGrid. So it was developed and basically invented to use with sand infill. So that was the intent when we developed this technology back in the late 70s. As shown in the previous projects, the geob infill is spread out with a dozer. A lot of times installing geob infill and just driving over the surface provides adequate compaction. Compaction with a drum roller sometimes really isn't even needed. From this muddy mess that require constant maintenance, additional material and high maintenance costs, to this clean, well-graded surface that will support the heavy loads, but also drain without the issues associated with a poor quality subgrade. Here's a really interesting project we did. This is actually in Western Australia. A design build project. We worked with a contractor to develop the design. The subgrade had not a bad CBR, it's about 2.5%, but you can see the large and heavy LNG facility which needed to be transferred. Probably about 10 miles to the site. You can see the facility had 26 axle loadings, about 60,000 pounds each, Tire pressures, 150 PSI. So we worked with the contractor to prepare a design solution based on about 5.5 million passes and a 30-year design life. And we use the OST roads method for this evaluation. Here you can see the cross section we developed with the contractor. It was a very interesting design since we had to design the cross section not only for the load support, but also for the reinforced slope to make sure the section did not globally fail on the edges as that heavy vehicle accessed this roadway. So design consisted of 2 layers of geob, one at the bottom, one at the top, 4 layers of high strength woven geotextile. Basically, 3.5 meters in height, so about almost 14 feet, with side slopes of 2 to 1. And here you can just be more of an up close, so here this is a 2 to 1 side slopes. We put down a layer of the woven geotextile, a layer of geob infilled with local sands, just to allow the vehicles to build this site. 1 meter of fill, another 1 layer of woven geotextiles, a meter of fill, another woven geotextiles, 1.5 meters of fill, another woven geotextile, then a mid-sized GW30V6 filled with local sand, and then topped with a 6-inch wear surface. Here you can see just an overhead photo showing the first layer of woven geotextile being installed with the white layer at the left side of the slide. Moving to the right, you can see the first layer, that's the geob in the black being filled, and moving to the right, just a closer picture, you can see these was a very wide road. You can see that each one of these geotextiles is about 15 feet. So we had 1, 2, 3, almost, there was 10 of these, so 150 feet in width. Here you can see that first geob panel going down, and then building up, and then going back to the sea. For all of our projects, we provide free design evaluations. For unpaved roads, we used, the basis of the Boysen-Etzke equation, along with, 40 years of research and testing and geob improvement factors to come up with an adequate factor of safety for your project. We walk you through the entire design process so you and your customer understand exactly what we're doing. We provide all the necessary information that backs up our design, so you have certainty in what you're actually going to be building. For unpaved roads with a lot of passes, we use a modified version of the Giroux-Hahn method, same method used by the geob and geotextile manufacturers. We typically run this evaluation when the passes are over 10,000 for the service life, but if you're interested in this evaluation, we can also add this for any type of project. So one of the big questions we get is about cost. No surprise, especially if it's a newer technology. We're having an idea of how much a geob system costs compared with other stabilization techniques is very important. So here we have a basic comparison for the geob system for a load support application. In this case, a low CBR. This comparison shows the difference in both price and cross-section depth for an aggregate only, an unreinforced section, a section using geogrids and geotextiles, and then 2 sections showing the use of geob system, one filled with crushed aggregate and one with a low-quality on-site salvaged infill. So you can see the geob system is both thinner and less expensive than the other methods. Significantly less expensive when on-site material is utilized. Of course, these costs will change, based on the mileage from an aggregate source. So, but this is a good starting point. So one of the factors of using geob, you must remember, is, like I said, is we can use that low-quality aggregate, sands, reject screenings. So we've been getting a lot of requests for value engineered projects lately after the bid, so that the contractors cannot source or even find enough high-quality aggregates for their projects due to those aggregate shortages. So in summary, the geob system can be added for your project to provide a more stable and longer lasting surface course for unpaved areas, which reduce maintenance costs and repairs. Geob can be filled with low quality materials, including sand, crusher screening rejects, pit run, or any recycled material. The ability to use these low quality aggregates or even sand can save a significant amount of money, especially at remote installations. Since geob significantly reduces the stress for reaching the subgrade, the cross-section depth can be reduced. Geob provides reinforcement to allow the system to perform over extremely soft and wet subgrades, handling heavy loadings. Once again, we offer a complete solution for all of our projects based on projects' specific details and conditions. And I can't stress this enough also, is we do not recommend using standard tables for any design, no matter the size of your project. So if it's a small project, 100 square feet or 1 million square feet, we're still going to give the same amount of support. And we have a very detailed website at www.prestogeo.com with many tools available to assist with your projects. We have quick links on the top of the screen, our products, application, our design section. Here's all of our installation manuals and links. We have a learning section. And the learning section has all of our pre-recorded webinars. You can actually log in and sign up. So part of our solution, like I said, is that technical assistance. So we provide, the free project evaluations. You basically just click on the request for a free project evaluation. You fill out the form. You can attach documents such as geotech reports, drawings, the evaluation. The information will come to us. Usually in about 2 days, 3 days, we'll provide the full evaluation. If we have questions, once again, we'll reach out. So after you click on the free project evaluation, this form pops out. It's very easy to, easy for it to follow. So you just click on the tabs through the form and provide the requested information. If you don't know something, because it does ask for not a lot of information, but if you don't know something, just skip it. And if we need that, we'll come back to you and ask for more information. So we've made it faster, easier for you to obtain your PDH certificates with our webinar dashboard. So you can easily view our library of webinars and download PDH certificates for on-demand webinars that you completed. So your webinar dashboard will keep a record of on-demand webinars that you completed along with the PDHs earned. So please note that certificates for the live webinars like today's are managed separately from this on-demand webinar. So you won't find your certificate from today in there, but you will receive an email from GoToWebinar within the next couple of days containing a download link to obtain your PDH certificate. If you don't receive that email in a couple of days, you also receive, so basically in a couple of days, you'll also receive an email from Presto with more information about accessing the on-demand webinar dashboard with other helpful information and resources. So if you don't receive that email in a couple of days, please check your spam folder or actually reach out to one of us and we can assist to make sure that you get that PDH credit. So thank you so much for taking the time out of your busy schedules to join me today. My contact information is listed. If any questions come up later, please reach out. As I mentioned earlier, if you don't have information to fill out the evaluation, just give me a call, send me an email. We can discuss the project for using Geobe on your project. And just to mention, we understand that Geobe is not the best solution for all of our projects. And we have the best distributors around the world, and we can make sure that if Geobe is not the best fit and is not the most appropriate product to meet your project specific challenges, we will hook you up with our distribution network to make sure that they push you in the right direction. So if you have any interest in other of our solutions, including our slope protection, channel protection, or gravity or reinforced walls, please let us know. Just so you know, we do have a free program that's available to design reinforced walls. So thank you very much for your time, and I guess we can see if there's any questions. Oh, here we go again. Question. Okay. Quite a few questions, but my box is not opening. How much it costs to use the system to cover an acre of unpaved road? Like I said, it's all depending on what type of system we go with. So we'll do that free evaluation. The best thing is get in contact with us. We'll do the free project evaluation, and then you'll know what the cost is going to be, so we're not just guessing on what system it's going to be. Can we use fine grained soils such as sandy silt or silty clays as infill? Yes, you can use fine grained soils as infill. Typically, we want to limit those to about 10%. So we have used the silty soils for infill, like so we're going to limit that to about 10%. How many years of scientific data? Have you had to show your system? We've been around as long as GeoGrids and geotextiles have been around. So we have over 40 years of research and testing data. Especially we got some really good research and testing data recently with the finite element analysis. So really some really good information out there. Been used to strengthen the soil under building foundations. Yes, we have. We've actually used it to basically spread out that stress on our building foundations. We've also used it for pile caps, so on top of pile caps. We've used it for flood dike protection. Yes, all over the world actually. You know, that's the great thing about this. We have a ton of research at Colorado State Hydraulics Lab, whether you fill the geo with concrete, topsoil, vegetated, or aggregate. So if you're interested in that, please reach out. I can show you that research that we've done. You have double or triple water stone. I don't understand that. But how to deal with snowfall during the winter install? If geo is covered with snow, is prepared thereafter. Typical. We're recommending for any type of application with the geosynthetic that's close to the surface. We have that wear surface that is going to freeze, but we always want to keep your plow blades with the discs on the bottom, so it's not scraping up that. This webinar will be available. Someone asked if it's going to, it will be available under the learning section of the on our website. Let's see here, the GeoBuffer advantage and reclaimed at the end of the project. I guess there's a question about geo being reclaimed at the end of your project. They're asking if you can reuse it again. If it's pulled up, that answer is typically no. It takes too long to try to pull it up. Any tips on reclamation? That's the same question. One's about the DOT approvals. We've got the GEO approved in a lot of the DOTs, especially now with we've done a lot of work on the DOT roads all over the U.S. Typically, it's not a problem getting accepted, especially with the new Technology Act. That's not a problem. Well, compaction, whether it's needed or not, like I said, it all depends on how much you access the pad during construction. If you want to drum roll it, it's important when you're compacting GeoPad that you don't over vibratory roll it, because you can actually pull the sections right out. So you want to make sure that you don't do that. What is meant by clean stone? Clean stone, I would say you just want to limit the fines to about 10%. So what I said about the infill, why is it different than geogrids and geotextiles? Why can we use that low friction? Well, it's basically confinement. Geogrids and geotextiles are planar elements, so they need that high friction angle to lock up. We have 6-8 inches of confinement. And with the geotex or geogrid or geoweb, we want that vertical load to be, basically going horizontal as fast as you can. So the lower the friction angle, the quicker that load goes from a vertical load to a horizontal load and engages the cell wall and gets that hoop stress going to support the load. So that's the big difference between geocells and geotextiles and geogrids. So I guess with that, I think I've got all the questions. If I missed your question, please reach out. Like I said, my email here, brian.wadine@prestogeo.com, and we'd be more than happy to help you out. So with that, once again, thanks for joining, and have a great day.